All right, geometry, it's time for the second part of our lesson 1.1. This time we are measuring angles. So our learning target for this lesson is we are going to be able to use the properties of angles to determine their measures. Our lesson overview has a few main ideas, including angle components and types. This should be mostly review. We're going to talk about angle congruence, or same measured angles. We're going to talk about lines that bisect angles or cut them in half. And we're going to talk about the angle addition postulate. Again, just a reminder, you're going to want to follow along in your fill-in-the-blank notes, your guided notes, and complete additional practice problems as we move along. I'll give you time to do that. Right, so let's define angles. An angle, let me switch up my color here. An angle is formed by two rays with a common endpoint. And a ray, let me just draw a ray off to the side here. A ray is kind of like in between a segment and a line. It has an endpoint, and the rest extends forever. So let's call this ray X, and then the next point is Y. The notation for rays looks like this. So you're using 2 points to define the ray, and the end point does not have an arrow, but the point going outward into infinity does have the arrow. This is ray XY. So one more time, an angle is formed by two rays with a common endpoint. In the diagram here, you see ray BA and BC. Their common endpoint is B. This common endpoint, B, is called the vertex of the angle. Some of this vocabulary may be familiar to you. The rays are called the sides of the angle. So ray BA is one side of the angle, ray BC is the other side of the angle. You need to name an angle using 3 letters or the vertex. I do want us to get into the habit of naming angles with all 3 points that are defined on the diagram. The middle letter must always represent the vertex. So in this example, this is angle A, B, C. And since this angle is kind of by itself, we can also call it angle B. That is also acceptable. So just like I said, use a single letter if there is only one angle located at the vertex. When referring to the measure of an angle, we need to use a lowercase m. So when you see this notation in the example here, when you see that m angle ABC, that's really just saying the measure of angle ABC. So we don't actually say M angle ABC, we say the measure of. And this specific angle is 60 degrees. Now this should be review. The types of angles. Our first one, going from left to right, we have an acute angle. And acute angles are less than 90 degrees. Next, we have an obtuse angle, and those are greater than 90 degrees. Next, we have our right angle, and it's labeled by the square in the vertex of the angle, and these are always equal to 90 degrees. And another angle you may not have heard of before. It looks like a line. It honestly is. This is a straight angle. This is a straight angle, And really, it's two right angles put together. And if you add that up, this is equal to 180 degrees. Pretty cool. So let's practice labeling some angles here. We are going to name the vertex of this angle in example 1. The vertex of the angle is where the two rays meet, where their endpoints meet. That is point K. So you can either write point K or just capital K. Now we need to name the sides of the angle. Remember, the sides of an angle are just the rays. So I see ray KL. Remember, the endpoint doesn't have an arrow, but the other point does, going out into infinity. Ray KL and ray KJ. Those are the sides of this angle. Now we need to give 3 ways to name the angle. Well, first, since this is an angle that's kind of by itself, it's not attached to any other angles, we can call this angle K. We can label it by its vertex. We can also call this JKL, going from the outside to the vertex back to the other side. So angle JKL. Or we can name it backwards, angle LKJ. All 3 of those labels are perfectly acceptable. Now we just need to classify the angle. This angle very clearly is greater than 90 degrees, so that means it is obtuse. There you go. There's additional practice for this type of problem, and that is example 2. So stop here if you would like to practice that. Note about congruent angles. We said in our last part that congruent angles, or congruence in general, means same measure. Again, congruence, same measure. So let's look at the diagram on the right. We see angle A and angle B are both 75 degrees. If the measure of angle A is equal to the measure of angle B, because they're both equal, 75 degrees, then the angles are congruent. This is written as follows. We're not using the M in front of the angle anymore. We're saying angle A itself is congruent. There's that symbol again, the squiggle with the equal sign. I know, not very mathematical. It is congruent to angle B. We will be using congruent symbols very often in this class. All right, now into more measuring angles, things that divide angles. Let's look at angle bisectors, and I'll switch up my color here. Okay, let's talk about angles bisectors first. An angle bisector is a ray, meaning it has an endpoint and then extends out into infinity, that divides an angle into 2 congruent, same measure angles. So in this diagram to the right, ray BD. Ray BD is an angle bisector. Therefore, the separate parts are congruent. ABD, the angle on top, is the same measure as angle DBC. Angle ABD is congruent to angle DBC. Something important to note, when we label congruent angles, let me draw a quick diagram here. Okay, let's say these 2 angles I drew are congruent. We label that they are congruent using arc marks, meaning inside the angle we make an arc. This tells us these 2 angles are the same measure. Okay, moving on. Perpendicular lines. These are 2 lines that intersect, at a right angle. And this one should definitely be review for us. Perpendicular lines are two lines that intersect at a right angle, like the diagram shows. The symbol for perpendicular is like this. It's kind of like an upside down T. In the diagram to the right, line L, remember that script letter, is perpendicular to line M. They meet each other, they intersect at a 90-degree angle. And next we have perpendicular bisectors. So a perpendicular bisector, I know this is vocabulary heavy, is a line, segment, or ray perpendicular to a segment at its midpoint. So let's break that down really quick. Perpendicular bisector does two things. First thing it does is it forms a right angle. Two lines cross, or two segments or rays cross at a right angle. And it bisects or cuts in half a segment. So segment PQ has now been divided into two congruent parts. So in the diagram to the right, line LM, and we're going to use the line notation, two arrows, is the perpendicular bisector to segment PQ, because we said it cut PQ in half. Again, notation for segments, no arrows at the ends, because segments end. For practice with defining these three angle measurements, you can look to examples 3 and 4, and feel free to pause here. All right, let's move into the angle addition postulate. Postulate just means a property that doesn't need to be proven. So in the angle addition postulate, here's what's happening. Let's look at the diagram given to us. I see angle ABC, and then ray BD is in the middle of it. If D is in the interior or inside of angle ABC, we can divide that angle into two specific angles, and it looks like this. Angle ABD, that's the angle on our left, angle ABD, plus angle DBC, that's the smaller angle on the right, right here. And we're not saying they're congruent, we're just saying that they are next to each other. And these angles added up should be the measure of the entire angle. Just like before with the segment addition postulate, part plus part equals whole. That is the whole concept. If you can understand part plus part equals whole, you should be good to go here. Let's talk about some examples. For problems 1 and 2, we're going to refer to that same diagram. We have angle ABC, and it is partitioned by ray BD. So in number 1, if the measure of angle ABD is equal to 48 degrees, and the measure of angle DBC is 78 degrees, we just need to find the measure of angle ABC. So again, part plus part equals whole. All we need to do is add up the 48 degree angle and the 78 degree angle to find angle ABC. So 48 plus 78 is 126 degrees, like so. Let me try to erase here. There we go. And let's look at number 2. For number 2, If the measure of angle DBC is 74 degrees, let's label that here, and the measure of angle ABC is 119 degrees, so the whole angle is 119, we need to find the measure of angle ABD, that smaller angle. So in this case, we need to take the whole, 119, and subtract the part, 74, to find angle ABD. And 119 minus 74 is 45 degrees. Let's apply some algebra, our favorite. Let's look at number 3. In number 3, if the measure of angle PQR is equal to 141 degrees, we need to find each measure. That means we need to find x, and then we need to find all of the angles here. So we need to set up an equation. I want to model it with the angle labels first. So let's go part plus part equals whole. Angle PQS, that's one part, right? Plus angle SQR over here on the right should be equal to angle PQR. That's the whole. Part plus part equals whole. Now we can go in and write our equation. 13x plus 4 is the expression used for angle PQS. Let's write that. 13x plus 4 plus angle SQR, which is 10x minus 1. And that's equal to angle PQR, which is 141. So let's combine like terms. I see 13x and 10x. I'm going to combine them to get 23x. I'm going to combine 4 and negative 1 to get positive 3. And that is equal to 141. Let's move the positive 3 over to the other side of the equation by canceling it out. I have 23x is equal to 138. Divide both sides by 23, and we are going to get a whole number here. X is equal to 6. So x equals 6. That's part of our answer done. But now we need to find the measures of the other angles, the parts of angle PQR. So to find the measure of angle PQS, we need to take 6, the value of x, and substitute it into the expression for angle PQS. So that would be 13 times x, which is 6, plus 4. And so angle PQS, 13 times 6 plus 4, that would be 82 degrees. So PQS is 82 degrees. To find angle SQR, we could go two ways. One way, we can take x equals 6 and plug it into the expression 10x minus 1. That's one way. Or we can take PQR, which is 141 degrees, and subtract it from the angle we just found, PQS. So 141 minus 82 would get us the measure of angle SQR, and that's going to be 59 degrees. No matter which way you do it, you should get 59 degrees for that angle measure. If you would like some additional practice with using the angle addition postulate and algebra applications, you can look at problems 4 and 5 in your notes, and you can pause here to do that. All right, that's the end of our lesson. Thank you for watching. Again, what to do next, make sure you are trying out those additional practice problems before our next class. Check your answers with my filled in notes. All of the answers will be sent to the content library of our class notebook in the Topic 1 Notes tab. If you need support, just ask in the Math Help Desk, and I hope you have a lovely day.